Let's learn the basics of how our algebraic expressions formed. Now, if we write 2 plus 3, right, let's quickly revise some basics. If we write 2 plus 3, this is actually arithmetic expression, right? But if we write 2x plus 3, it becomes a algebraic expression. And why? This expression doesn't contain any variable, but in this expression we have one variable, that is x. That makes it an algebraic expression. If you add a single variable here, or if you, let's say you simply multiply this with y times 2 plus 3, now this also becomes an algebraic expression, because now it has a variable here. Okay, that's the basic of the difference between arithmetic expression and algebraic expression. Now, if we say that we have a algebraic expression x squared, so how is it formed? You will say that it's formed by multiply x with itself 2 times. That is, it becomes x times x. Multiply x with itself 2 times. This gives you x squared. What do we say? We say x squared. We call it x squared. Or we say it x raised to the power 2. Similarly, x cube is formed by multiply x with x 3 times. Sorry, x with itself or x anything 3 times. Itself 3 times. So x times x times x. And what you get? X cube. What do we say? We say x cube or x raised to the power 3. X raised to the power 3. Right? In the same fashion, if it is x to the power, x raised to the power 100. So this will be multiply x with itself 100 times. 100 times. This is the way how it has been formed. So this is x times x times x and times, finally, let's say this is a 100th x. So multiply x with itself 100 times. You'll get x raised to the power 100. So if somewhere it is written like this, x times x times x times x, how will you write this in the form of algebraic expression? You will write it as, how many x do we have? 1, 2, 3 and 4. So x raised to the power 4. Now don't get it confused with this one, x plus x plus x plus x. If this is the condition, that is x has been added to itself 4 times, it becomes 4 times x. But if it has been multiplied 4 times, right? If it has been multiplied 4 times, then it is actually x raised to the power 4. So similarly, if your algebraic expression is y raised to the power 1000, and someone asks you that how this algebraic expression has been formed, simply tell them that multiply y with itself 1000 times. And what will you call this? Call this y raised to the power 1000. Okay. Now let's take some more examples. Let's take if this is 3 times x plus y plus 2. So you will say that the first step will be multiply 3 with x. So we get 3 times x. The second step will be add y to 3x. So you get 3x plus y. And then add 2 to 3x plus y. So you get 3x plus y plus 2. Right? So adding 2 to 3x plus y, you get this one. So in these 3 steps, simple steps, we can form this expression. Now, one very important thing, and it's important because when we'll move forward, we'll cover more topics in our discussion on algebraic expressions. There we will use a term called term of an algebraic expression, right? So for this topic, what I'm going to discuss now is very important. Let's say we have our algebraic expression as 3x plus y minus 2. So the first step, you will say that multiply 3 with x, so you will get 3x. The second step, you will say that add y to 3x, so you will get 3x plus y. Now third step, you will say that subtract 2 from 3x plus y minus 2, and that's actually correct. But it's better to think it in this way. You simply say, for the third step I'm telling, the best way will be you add minus 2 to 3x plus y. Okay, so this becomes 3x plus y plus add minus 2. This gives you what? Plus outside the bracket will make the finally will be minus. So 3x plus y minus 2. And why is it important? Because when we'll discuss about terms in an algebraic expression, then we will use one thing, that we will always say that terms, and this I'm going to cover in the next video tutorial. That's why this is really very important. Terms are added to form an algebraic expression, right? So like in this example, let me show you. 3x is one term, y is one term, another term, and 2 is another term. Okay, if you remember this definition that terms are added to form an algebraic expression, so this is term 1, let's denote this with t1. This is term 2, let's denote this with t2, and this is term 3. So we have actually added 3 terms, t1 plus t2 plus t3. In the same fashion, if we follow this definition and if we follow this algebraic expression where we are actually saying that add minus 2 to 3x plus y, then you can write it as this as 3x plus y plus minus 2. That is the same this one that we have already written here, right? So here in this case, 3x is one term, this y is another term, this minus 2 is another term. If we denote this one with t1, that is term 1, term 2, term 3, then it satisfies the definition. That is, terms are added to form an algebraic expression. Terms have been added here t1 plus t2 plus t3. What's t3? T3 is actually minus 2. So that means if somewhere you see this kind of this algebraic expression, let's say x cube minus x square and minus x and minus 1. Let's say this is our algebraic expression. You quickly write it as this way: x cube plus minus x square, because when this bracket opens, this will become minus 1, plus minus x, plus minus becomes minus, plus minus 1, plus minus becomes minus. So again, if you look at this definition, terms are added to form an algebraic expression. So this plus and this plus. So terms are added. So this is term 1, this is term 2, this is term 3, and this is term 4. Terms have been added to form this algebraic expression. What's term 1? Term 1 is x cube. X cube. What's term 2? Term 2 is minus x square. What's term 3? Term 3 is minus x. And what's term 4? Term 4 is minus 1. So this is really very important, that you always think of this subtraction as something has been added, some negative value has been added. We know that outside the bracket, if you have plus, and if inside the bracket you have minus, then final outcome is actually minus only, right? So this is the way to form algebraic expressions. If we take a very simple algebraic expression, let's say we take x only, and another algebraic expression, let's say that is x square, another one is x cube. So we have three algebraic expressions. And why they are algebraic expression? Because they contain variables. Okay, so in this first algebraic expression that contains only one variable, that's it, and this is x only. This is actually term of this particular algebraic expression. In the same way, this is also the term of the algebraic expression x square. And in this case, the algebraic expression is x cube. Even this is the term. Okay. What if our algebraic expression is x plus 3? Similarly, x square plus 3 and x cube plus 3. Now, in this case, all these three are algebraic expressions, and for this one, we have two terms. This is one term and this is another term. Similarly, in this case, we have two terms. This is one term, this is another term. In this case, again, we have two terms. This is the first term of this algebraic expression, x square, x cube plus 3, and this is another term, right? So for this algebraic expression, we have term 1, this is term 2. This is term 1, term 2, term 1, term 2. What's important thing is to notice this plus sign in all these three cases. In these three algebraic expressions, we had only one term. This is the first one term of this one, this is one term of this one, and this is the one term of this one. But in this case, we have two terms, x and 3, x square and 3, x cube and 3. And if you look at these plus signs, it tells us that terms add up to form algebraic expressions. Terms add up to form algebraic expressions. Okay, so some of you would think that, okay, is it only add up? What if our algebraic expression is x minus 3, x square minus 3, and x cube minus 3. Then what? Are they not algebraic expressions? Of course, they are algebraic expressions. Then the next question you will ask is, so here you said that terms add up to form algebraic expressions. What if we have, but here we have the minus symbol or minus sign. Okay, let's write this as x plus within bracket minus 3. This one as x square plus within bracket minus 3. And this one as x cube plus within bracket minus 3. We know that if within the bracket we have minus sign and outside the bracket we have plus sign, the plus minus becomes minus only. Same thing here, plus minus becomes minus, plus minus becomes minus. So think of this algebraic expression as x plus minus 3. Therefore, this will be one term and this will be another term. Therefore, the two terms of the algebraic expression x minus 3 are x and minus 3. These are two terms of this algebraic expression. In the same fashion, x square and minus 3 are the two terms of this algebraic expression x square minus 3. So the algebraic terms of x square minus 3 will be x square and minus 3. Same thing here. X cube is one term and minus 3 is another term. So x cube and minus 3 are the two terms of the algebraic expression x cube minus 3. So the point is, you have to remember this definition that terms add up to form algebraic expressions. Let's take a few more examples. What if your algebraic expression is x square y square z square minus 2x square y square minus 2y square z square minus 2x square z square? What if your algebraic expression is this one? Again, write this as x square y square z square plus within bracket 2x square y square minus, plus within the bracket minus 2y square z square. Then let me write this, cut this here so that we can demonstrate. Control X and Control V. This one as plus minus 2x square z square. Okay, so what are the terms of this algebraic expression? This one. So the terms are, this is term 1, this is term 2, this is term 3, and this is term 4, right? So your focus should always be on the plus sign, and wherever you see minus sign in an algebraic expression, quickly think of it as plus outside the bracket and minus within the bracket, right? So this is term 1, term 2, term 3, and term 4. Let's take a few more examples. Let's say we have x square minus y square minus xyz plus 3y minus 4. In this one, this is x square this is x square plus within the bracket minus y square plus within the bracket xyz plus 3y plus minus 4. Okay, so this is term 1, this is term 2, this is term 3, this is term 4, and this is term 5. Now, if you look at this term number 5, this term, this is actually a constant. This is actually a constant term. Why it is a constant term? Because this term only contains one numerical value, and that is -4. This term is what? -4. And why this is constant? Constant means that it will not change whatsoever. Come what may, it will not change. So the value -4 is going to remain the value -4. Doesn't matter how much or by what number these values, that is x, y, and z, change. Right? Because you know that if we put x equal to 1, then we'll get one value of this expression. But if we put x equal to 2 and y is equal to 1 and y is equal to 2, that's why they are variables. Variables means that their value can differ, and when their value differ, the value of whole algebraic expression will differ. So this term is x square. Its value is completely dependent on x. If I take 1, then the term 1's value is 1. But if I take 2, the term's 1 value is 2 times 2, that is 4. Right? That's why this is constant. Its value is not going to change because it doesn't contain any variable. Right? So this was all about terms. So we have now discussed about terms of algebraic expressions, and we learned what do we mean by terms and how do we find out terms of an algebraic expression. We're going to discuss about factors of terms of algebraic expression. Okay, let's start with the same basic, algebraic expressions. This is x, this is x squared, this is x cubed. So we have 3 algebraic expressions. Let's take the first one, that is x. Okay. In this algebraic expression, we know that x has only one term, and that is x. Now, if I take a number 30, and if I write it in the form of its factors, 2 times, 3 times, 5, right? This is in the terms of its prime factors. So we will say that 2 is a factor of 30, 3 is a factor of 30, and 5 is a factor of 30. 2, 3, and 5 are factors of 30. In the same fashion, whatever we have learned about factors in the case of numbers, we are going to apply here. And as we said that we find factors of terms. In this case, we have only one term, and that one term is x. So you can think of this term x as x times 1, right? X is equal to x times 1. But here's the condition. We never take 1 as a factor. When we are talking about factors of terms of algebraic expressions, right? We never take it. So in this case, only one factor is left, and that is x only. So for this case, for the algebraic expression x, there is only one term, that is x, and on this basis we say that x is also the factor of this term x. Okay, now let's take for x squared. If we take the next algebraic expression x squared, right? Again, this algebraic expression x squared has only one term, and that is x squared. And you can think of this x squared as x times x. So you have one factor this and another factor this, right? So x squared can be written as x times x, and therefore this is one factor and this is another factor. of the term x square. X square is the only one term of the algebraic expression x square, and it has two factors x and x. Okay, so this is factor and this is factor. If you are thinking that aren't both the same, yes, they are same, but you have to take them into account. Okay, so let's take the third one. Let's take the third one, x cube. Now, this algebraic expression has only one term. This algebraic expression has only one term, that is x cube, and this x cube can be written as x times x times x. Right? Now, those of you who are getting confused at how did we reach to this, x cube as x times x times x, for them, first video tutorial on how to form the algebraic expression that we have discussed today. I'll put the link to that video tutorial as well. Okay, so watch all those videos. Okay, how to form the algebraic expressions and about the terms of algebraic expressions. Watch them, then you will better understand this video. So this is x cube is equal to x times x times x. Now, clearly, this is one factor, this is one factor, and this is also one factor. So this x cube, the term x cube, can be written as x times x times x. This is one factor, this is one factor, and this is one factor. Right? So it has three factors. The term x cube has three factors, and these are the factors. Okay, let's take this one, x minus 3, x square minus 3, and x cube minus 3. Let's take for them. So first one is x minus 3. Okay, this algebraic expression x minus 3, you can, as we have discussed, that can be written as x plus minus 3, because terms always add up to form an algebraic expression, and we have discussed that whenever you see any subtraction sign, replace this with plus and within the bracket put minus 3, because terms always add up to form algebraic expressions. Now, it has two terms. It has two terms. One is x, so one is x and another one is minus 3. These are the two terms. These are the two terms of this algebraic expression. Now, this, if we talk about now factor, as we have said, factor is only of terms. So this is term 1, this is term, another term. For this particular term x, as we discussed here, the factor will be x only. And like we have discussed for this one, that we can write x as x times 1. In the same fashion, we can think of this number as minus 3 as minus 3 times 1. But as we said, that we never take 1 as the factor, so this will be only factor of this term minus 3. So the factor will be what? Will be minus 3, right? So these are the factors. X is the factor of the term x, and minus 3 is the factor of the term minus 3. Okay, let's take x square minus 3. X square minus 3. X square minus 3. Think of this as x square plus minus 3. One term is x square, another term is minus 3. So if you write this as, this is one term x square, this is another term minus 3. So these are the two terms of the algebraic expression x square minus 3. Now let's talk of factors. This can be written as x times x, right? So one factor is this, and one factor is this. In this case, only factor, so x and x are the two factors of x square. In this case, minus 3 is the factor, minus 3 is the only factor of this term minus 3, right? Let's take for x cube. Let's take for x cube. I'll do it here. So x cube minus 3. Think of this as x cube plus minus 3. Now, if you have to write the terms of this expression, this is one term and this is another term, right? So x cube and minus 3. These are the two terms. Now about factors. So the factors will be x times x times x. We can write this x cube as x times x times x. So this is one factor, this is another factor, and this is the third factor of the term x cube. It has three factors, x, x, and x, right? So what about this one? Minus 3. For this one, minus 3 is the only factor. So this is about terms. Sorry, factors. Now let's take the last, another one example, but the last one, and let's take this one. Okay, so let me copy this. So we have this algebraic expression, that is x squared minus y squared minus xyz plus 3y minus 4. Now this can be written as x squared plus outside the bracket within the bracket minus y squared plus outside the bracket within the bracket minus xyz plus 3y plus outside the bracket within the bracket minus 4. So we have first term as x squared, second term as minus y squared, third term as minus xyz, fourth term as 3y, and fifth term as minus 4. So we have 1, 2, 3, 4, and 5 terms. Let's take each term one by one and let's try to find out their factors. So first time terms is x squared. Now x squared can be written as x times x, right? So this is one factor, this is another factor. So if we have to write its factors, they are x times x. So these are the factors of the term x squared. The next term is minus y squared. Now here's the thing. Whenever you are dealing with a term which has minus sign associated with any variable, then you have to think of that term as, like in this case we have minus y squared. Think of this as minus 1 times y squared. Now this minus 1 remains as it is, and this y squared can be written as y times y, right? Just as this one. So one factor is minus 1, another one is y, and another one is y. So it has three factors: minus 1, y, and y. The next term is minus x, y, z. As we have done in this case, same process will be applied to this one. So minus x, y, z, you can think of it as minus 1 times x, y, z. This can be written in this form. And then this is minus 1 times x, y, z means what? X, y, z means, if it is x, y, z, it means x times y times z, right? So x times y times z. This is one term, this is next, this is next, this is the last one. It has 4 factors, sorry, not terms. This term minus x, y, z has 4 factors. So let's write all of the 4 factors. First is minus 1, then is x, then is y, then is z, right? Now next term is what? 3y. This 3y can be written as 3 times y. So it has 2 factors, that is 3, and next one is y. Now in this case, here we have the term minus 4. The factor of this one will be, since this is a constant, will be minus 4, right? So here we have terms and their corresponding factors.